One, two, three. The following video is on volumes of prisms and cylinders. So we've already learned surface areas of volumes and cylinders, and now we're going to talk about volumes. So now what we're going to take a look at is if we have an example, let's just take a cylinder, for example. A volume is if I fill this thing up with some sort of liquid or maybe rice or something like that, how much of that stuff could I fit into this thing? And so what I have to understand is, let's say I pour a certain amount of water in, green water, I guess. So let's say I pour a certain amount in and it's not all the way to the top. But what I would notice is that the shape that I see when I stop pouring it after it all settles in would be a circle. Then let's say I pour in another set of water, maybe it's dyed red, and then that's on the top, and there's some sort of way where I keep the red and the green separate. But what I would notice is that the top of this would also look like a circle. So no matter where I stop, it's all a bunch of circles. And remember last video we were talking about cutting these into the shape of the base all the way up to the top. So there'd be a bunch of circles all the way going up. So each of these things would be a circle going all the way up to the top. Basically what's happening is I'm taking the shape of the base and I'm multiplying it by the height. So the area of the base essentially gets multiplied by the height, and I'm stacking up a bunch of bases all the way until I get to the top. So the volume formula is taking the area of the base times the height. And that's true in both two base shapes. So anytime I have a simple two base shape, it's area of the base times the height of the solid. Now remember, the area of a circle is pi r squared. So if I wanted to get a special formula for a cylinder, I would call it pi r squared times the height. But that's not necessary as long as you remember that that's the formula. So we're going to end up doing some volumes with the exact same shapes that we did with surface areas in the last video. So if we take a look, what we want to do in this triangular prism is, remember the triangle's the base, and if I poured water in this with the triangle on the ground, what would end up happening is a triangle would show up every single time as I continued to pour it further and further up. So I'm basically taking the area of this triangle and sticking it all the way up to the top, and it forms a volume. So what I'm going to do here is I need to find the area of the base, which if we remember from the previous video, I can do the Pythagorean theorem and get this side to be 24 inches. So that's 1/2 times the base of the triangle times the height. So that ends up being 84 inches squared. The height of this figure is 30 inches because if I stuck the triangle on the ground, the 30 would be going up in the air. So that volume is going to be area of the base times the height, which is 84 times 30, which is 2,520 inches cubed. Notice that volumes are inches cubed or units cubed because I'm finding a three-dimensional thing. Oh, and I kind of gave away what the answer is going to be. But remember last time we could calculate the surface area using anything as the base? Well, we can do the same thing with volume if I have a rectangular prism. So notice that I've already done the front and back and the left and right. So I'm going to calculate the volume if I use the top and bottom as the base. So top and bottom as base. What I will do is the area of the base is 7 times 8, which is 56 centimeters squared. Then the height is going to be 21 centimeters. So base times height is 56 times 21, which is going to be the volume. So I kind of messed these up a little bit. Sorry about that, guys. So Those are volumes as well. So the volume 56 times 21 also gives me 1,176 centimeters cubed. So that's the volume there. Now in this octagonal prism with an octagon base, I have already kind of calculated the area of the base, which if you want a refresher on how to calculate the area of the base, you can watch the surface area video because this is the exact same problem. So I have the area of the base, which is 268.410 meters squared, and the height is 35 meters. So then all I have to do to find the volume is do base times height. So that's 268.410 times 35. And so the volume is 9,394.364 meters cubed. And once again, I did not round it all in the calculator. I actually kept way more decimal places than 3 in the calculator, but if you rounded, your answer will be slightly different. Now to cylinders, the base is a circle. So in this problem, the radius is 7. So the area of the base is pi r squared, which is 49 pi inches squared. Then the height is 19 inches. So the volume is area of the base times the height, which is 49 pi times 19. So the volume is going to be 931 pi inches cubed, which if I rounded it, it's about 2,924.822 inches cubed. And if I were being a little bit more technical, I would put the squiggly equal signs there. Finally, this radius is 3. So pi r squared gives me the area of the base, which is 9 pi. The height would be 8, because if I stuck the circle on the ground, the height of the figure would be this length, which is 8. So I would find the volume to be 9 pi times 8, which is area of the base times the height. So that's 72 pi centimeters cubed. That's the exact answer. If I wanted the rounded answer, I would type that in the calculator, and I'd get 226.195 centimeters cubed.